In this video, we're going to review things like line equations, how to graph things, a little bit about understanding the compass and how the ACT uses that, and how we look at lines and recognize what the slope is and what the y-intercept is, and what is that information telling us. So we're going to start with the basic construction. It starts with y equals mx plus b. Now we know that y is the part of our axis that's going up, and x is over here. Typically, we think of our y values as being some relationship to x. So if I draw the simple line where I have y equals x, that means if x is equal to 1, then my y value is also equal to 1. If I have 2, then I'm going to go out to x equals 2 and y equals 2. So I get a straight line. It goes through the origin 0, 0, because if x is 0, then y is 0. So the y-intercept in this case would be 0, and that's what makes the equation y equals x. Look, actually, if you think about it, it's going to be y is equal to 1, which is my slope, x, plus 0, which is my y-intercept. Okay, so I wanted to give us just a little bit of a start. Now we're going to take a look at one where we start to change things a little bit. Let's say we're going to do y equals 3x plus 2. Okay, in that case, what this is telling me is if I let x equal 0, x is equal to 0, that means I have y equals 2. So I go to my x value of 0, which is the y-axis. And that means I would go up to 2. This line has a y-intercept at 2. Now, the 3 being positive means my slope is going up. A negative slope means it's going down. So in this case, I have a 3x. That means if I let x equal 1, I would say y is equal to 3 times 1 plus 2, y equals 5. So at x equals 1, I'm going to go all the way up to 5. Now I have a line that looks something like this because it has a very steep slope. If it was the other way around and I said y is equal to, and in this case instead of 3x, I'm going to say 1/3 x, and we'll say minus 2. Now we'll take a look at that with a little different color. We're saying let x equal 1. That means y is equal to 1/3 of 1 minus 2, which means y is equal to 1/3 minus 2. Well, 2 is actually 6/3, so that means y is equal to minus 5/3, which is equal to a minus 1 and 2/3. So we'll come down, that would be a y equals 1, y equals 2. We're talking about some point right here. But since it has a slope of 1/3, remember, slope, this is the most important thing about slope, and it's the place that most people make mistakes. Slope is equal to your rise over run. Now, where a lot of people make the mistake is they look at the x-coordinate. Let's just say we're going through the point 4, 5. And whenever they're calculating the slope, say, let's just say from 1, 3 to 4, 5, they always think, since the x values come first, they go on top. Exactly opposite, because your rise is your y values. So I would set up the formula here as y2 minus y1 over x2 minus x1. So if you look at that, using these values, I'm going to have a 5 minus 3 over 4 minus 1. And when you do the math on this, you're going to get a 2 over 3. All right? So that just gives you a little bit of idea of what this slope means. So when I look at a slope of 1/3 back over here, that means I'm going up 1 over 3. So that would be a 2 on x. That'd be a 3 on x. So I'm going up 1, which would be to here, and over to here. So my line would look like this. That would be the line y equals 1/3 x minus 2. Still a positive slope, but a negative y-intercept. Okay? So this is getting a little messy. I'm going to take a second and clean this page up, and then we're going to pick up and continue with some more. Okay, now we're going to pick up and look at a little bit more. Sometimes the ACT will ask the question like this. They'll say, what is the slope of the line going from 3, -2 to 5, 5? Okay, so we'll look at this two ways, one from the equation and the other from graphing it. So first we'll start by graphing it, which helps us get an idea. If we graph this, we're going out 3, 1, 2, 3, and down 2, 1, 2. That would be the point 3, -2. Now we look at the next point, and we're going to go to 5. That would be 4, this would be 5, and we're going up 1, 2, 3, 4, 5. Okay? Now, one of the things you'd want to do is get into the habit of saying, okay, I am really going up. This is a positive slope. That way you don't mess up with your signs. So you would have a line that looks like this going to 5, 5. So now we're going to do the math. The slope is equal to y2 minus y1 over x2 minus x1. And I've already labeled these. This is my x1, y1, x2, y2. So I'm going to take the 5 on top minus. The formula calls for a minus. But notice what the ACT likes to do is they love to throw negative signs in and make sure you know how to use them. This is a -2, so I'll write it in again as a -2. That tells me I'm going to be adding those. Now I have 5 minus 3. Okay, so this is going to give me 5 minus a -2 is 7 over 5 minus 3 is 2. My slope is 7 over 2, or 3 1/2. So if I was going to write this equation again, it would be y is equal to 3 1/2 x plus whatever the y-intercept is. So I wanted you to see how we use this equation. Now what we'll do is take a minute and look at how the ACT sets these things up using the graph with your compass coordinate points. Okay, now we're going to take a look. When we talk about the coordinate points, and the ACT likes to do this, they've got quite a few problems where they'll do something like this, and it's usually laying out a city in grid blocks, okay? Most cities, or a lot of cities, have square blocks, and you could think of it in terms of an XY coordinate plane. And so this would still be our y-axis, and this is our x-axis. But when we use it with a compass, this is what we call north, that would be south. This is our east, is the positive x, and west is negative x. Now, a typical problem, the ACT would say, a wrecker truck is located at a point of 3, 1 in the grid. Or they may say that it is 3 blocks east of headquarters and 1 block north. All right, 3 blocks east, 1, 2, 3. Here it is, 3 blocks east and 1 block north of headquarters. When they tell it to you like that, they're telling you, without saying it in words, they're telling you this is headquarters, 0, 0. They didn't say that. They expected you to know that if it is 3, 1 north of headquarters, headquarters was at my 0, 0 point. Now what we're going to do is they will continue the problem, and they will say, an accident has occurred at a point -9, -4, or 9 blocks west of headquarters, 4 blocks south of headquarters. 9 blocks west, we come over here, -9. 4 down here, -9, 4. That is 9 blocks west and 4 blocks south of headquarters. And they will ask you, how far is the wrecker from the accident in a direct line of sight? The easiest way to do these is to make it into a right triangle. Most of the time, the ACT sets this up so that you're going to get numbers that match with your 5, 12, 13 or your 3, 4, 5 triangles. So if you look at that, what you have is, I would start this out to get this distance here, would usually be using a distance formula. But I like to make things easy, so I want to use my triangles. And I say that on my y values, this part right here is my y values. On my y values, I went from 1 north to 4 south. Okay, that's 1 getting to here, and 4 to here makes this distance of 5. Now, as soon as I see a 5, I start thinking 3, 4, 5, or 5, 12, 13. So now I go to the next one. On my east-west, I went from 3 east, that means this distance is 3, to 9 west. That gives me a 9. That makes this 9 plus 3 is 12, so I know I have a 5, 12, 13 triangle, and my straight line distance is 13 in this particular case. So this will help you understand what the ACT is talking about when we mix coordinate points with the XY coordinate plane. We took a look at slope. We're going to work through some problems now that are from former ACT tests that will help us get an idea how the ACT wants you to work your way through these using your understanding of lines and the XY coordinate plane. What you want to do now is make sure you've printed out the PDF. It should be on the page where it's a downloadable link for you to download it with this video. I would pause the video, work through the 10 problems that we have. It's going to be 11 pages because one of them we're just going to explain when we get to it. And then come back and unpause the video after you have tried to work these problems. As soon as you get them worked, then you go ahead and start the video again, and I will go through each and every one of them. And by the time you get through with this video and working these problems like this, I hope you have a really good understanding of how the ACT presents the slope intercept problems and the line equation problems on the ACT math test. We're going to start with this problem. First of all, it tells us that a boat leaves a dock and sails directly north for 5 miles. It then turns and sails 12 miles east. How many miles is the boat from the dock? So this one immediately tells us that we're working with an XY coordinate plane, remembering that our north and south are the y-axis and our east and west are going to be the x-axis. So now we'll go back and look at it. It tells us we went north 5 miles, okay? So we're going to say that's 5. And then east 12 miles. So that's a little bit like that. So it's going to be 12 east. Remember our x directions come first, and 5 north. So that would be the point we're looking at. Now it says how many from the dock. Well, it doesn't tell you where the dock was, but the way they've worded it tells you that it is actually 0, 0. So now they want to know how far is it from here to here. And the easiest way to do it is to make it a triangle, which, since this is 5 north, tells me that side of the triangle is 5. 12 east tells me this is a 12. So now we use our a squared plus b squared equals c squared. Or we can remember that this is a Pythagorean triple, 5, 12, 13. If you want to do it the long way, that would be 5 squared plus 12 squared equals c squared. And we get 25 plus 144 equals c squared. 169 equals c squared. And then the square root of c squared. And the square root of 169 tells us c is equal to 13. Making that the answer for J. Now we look at the next one. And it tells us this is one we're not really going to work a problem in. I wanted you to see how the ACT is using the graphical information to tie into what they want you to do. All right. So it tells us a bunch of stuff at the front, but I'm going to pick up right here where it says she graphs in the 3 weights and corresponding microwave defrost times in the standard XY coordinate plane as shown below. She notices that there is a linear relationship. That means you can draw a straight line between these points. She finds that the equation of the line is y is equal to 420x plus 10. So if you drew this straight line through here, its expression would be y is equal to 420x plus 10. Okay, now the axis is not the same here. This axis, we are plotting weight in pounds. And this one is giving me defrost time in seconds. Well, there's not a relationship between those two. So that's why the graph doesn't look like it's almost vertical in the way they've drawn this. Because that would mean like you'd be saying that 1 pound would equal 1 second, which would make it a really skewed graph. So they've done it this way. Now here, let's look at the coordinate points that she's given us. And she's given us 0.9. That's my x-axis. That means 0.9 pounds right here. And it's 388 seconds, so we're almost up to the 400. The next one tells me we're at 1.5 pounds, and it took us 640 seconds. And the next one says 2.4 pounds took us 1,018 seconds. To get minutes, we'd divide by 60. Okay? Now, what we're going to do is look at that in the next problem. In the next problem, you see we pick up with the same graph, but now we actually have a problem to solve. Number 23 down here. And number 23 says, how many seconds longer is the microwave's defrost time for 2.4 pounds than for 0.9 pounds? So we're talking about the defrost time. Remember, time is on my y-axis. So 2.4 then 0.9. So what I know is it takes me 1,018 seconds at 2.4. It takes me 388 at the 0.9. So now all we have to do is subtract them. It says it takes how many seconds longer? Okay, so this is going to give me a 0, and then I'm going to take an 8 from 11. It's going to give me a 3, and that's going to make this 9, and 9 minus 3 is going to give me 630, which would make C the answer to number 23. Now we see that we have another one of these. Points minus 2, 3, and 0, 1 lie on a straight line. What is the slope-intercept equation of the line? Okay, let's take a second and draw it out. If we draw this line out, you'll see that we have the points minus 2 on x and 3 on y. Minus 2, 3. And we have the point 0 on x and 1 on y. 0, 1 is this point right here. All right? So when we look at those, right away we can tell that our line is going down. So we're going to have a negative slope. So that would narrow us down to just answers J and K. And an easy way to do these is to say, I'm going to take this value of x and plug it into the equation and see if I get that value for y. So if I take the first one, and I said that would be saying 3 is equal to minus a minus 2 plus 1. Well, that works because that gives me a 3, which is just the 2 plus 1. All right. And so now we test it with the second set of points. It has to work with both of them. So if I do this one, I'm saying 1 is equal to minus 0 plus 1, and it is equal to 1. So that works, and that works, which would make J the answer to this one. On this problem, we have what is the slope of the line represented by this equation? Well, the first thing we have to do is remember that our expression should be y is equal to mx plus b. All right, that means we rearrange this equation, 6y minus 18x plus 6, so that it looks just like this one. And that first step is going to be to add 18x to both sides. Okay, so that's equal 6. All right, so now what I'm going to do is add an 18x over here, and this gives me 6y equals 18x plus 6. Now remember, when you look at this, and this is something that a lot of people do, is they just add the 18x on the end and have a 6 plus 18x, and it sort of gets confusing because you're trying to find the m, and that should stay your first value. The next thing we're going to do is divide both sides by 6, And I always like to break this up so that I can keep it separate. If I draw one line all the way across, it tends to make me get a little confused because I'm trying to find the slope. So this is going to give me y is equal to 3x plus 1. So that tells me that the slope has to be 3 and gives me g as the answer. This is another one, same type problem. Wanted to see if you're getting better at these. 2y equals 6x plus 4. Well, the first thing we're doing is leaving it just like that. Notice what I did. My very first steps, I added the 6x to both sides. And I rewrote it like this. Now, my next step is divide everything by 2. 2 and 2. So this is going to give me y is equal to 3x plus 2. So the slope, once again, is 3 for this one. Now we're going to take a minute and look at this one. This is one where they've given us the information in graphical form. Now what we need to do is understand it and pick the right answer. It says the graph below shows the distance d miles. You are from home t hours following the start of a walk. Which of the following statements accurately describes your walk? Okay, when it says which of the following, just like I've covered in science, which of the following means work your way through the answer choices. There's no way to calculate this and determine what it is. You just check to make sure that the answer choice matches what you see happening. You start at home, okay? Start at home. This is 0 hours, but I did not start at home. I started 6 miles away from home, okay? That takes out this one. Didn't start at home. Didn't start 12 miles from home. I ended 12 miles from home. And this one says I start 12 from home, and after 2 hours, I'm 6 miles from home. That is not correct. All right. So now what I'm doing is I'm down to K. I started 6 miles from home. Yes. And after 2 hours, I was 12 miles from home. Yes. Okay. Now, sometimes people tend to get a little confused with this and think, well, my actual distance is this distance here, and think that there's got to be it's a little trig work to make this, to determine what that distance is. No, they told me that my y-axis is my distance from home. So my course could have looked like this. It doesn't matter. When I got to that point, I was 12 miles from home, and it didn't matter what the path looked like. I was not walking in a straight line. Hopefully that'll help you see how they work with these. Now we get another one of these. These points line the standard XY coordinate plane. What is the slope of the line? And in this particular case, we're going to use the formula slope is equal to y2 minus y1 over x2 minus x1. Well, this is going to be my values. Up here, this is x1, y1, x2, y2. So the first thing I start with is my y values, and they go on top. So that tells me I have a 5 minus 4 on top. I also on the bottom now have a minus 4 minus 6. This is going to give me a 1 on top over a minus 10 and makes F, the answer to this one, a minus 1/10. This one has a few more minus signs in it. We see that we're going to look for the line going through the points minus 4, 1 and minus 6, minus 3. So if you just want to get a quick visual on this, minus 4 on the x-axis up 1. That would be this point, minus 4, comma 1. Now we have a minus 6 is a little bit more negative, and down, minus 6, comma minus 3. Now we can picture that going like this. So what we're looking for is what is the slope? Right away, you should see we're increasing, so it should be a positive one. But we're going to go ahead and work on this. This is going to be my x1, y1, x2, y2. So I have a minus 3 minus 1 over. Now we come back, x2 is a minus 6 minus a minus 4 is equal to a minus 4 over a, now we have a minus 6 plus 4 gives me a minus 2. Minus 4 over minus 2 gives me a positive 2 for the slope, making K the answer. I wanted you to see this one since it's getting a little bit more complicated, but it's along the same line. It tells us these points lie in the standard XY coordinate plane. If A, B, C, D is a square, then what is the length in of the coordinate units of CD? Well, we're going to look at a few things on this one. All right. First of all, the point minus 3, 0. This is going to give us an idea of what's going on. Now, this one's going to give me the point 0, 3. And this would be 3, 0. So when you look at this, what you have is they told us it's a square that would look like this. Since this point is 3 above the axis, the x-axis, this one would be 3 below it. So this one would be at 0 on x minus 3 on y. But it really doesn't matter because that's not what they ask us. They ask us what is the length of the units of CD. Well, that would be this line right here. Well, we could do it using these points, but since it's a square, all sides are going to be the same. I'm going to do it using this one because my x value, making the length of this triangle 3, and my y value there makes that side 3. What I have is a 90 degree here. This is 3, this is 3. That means this is a 45, 45, 90. Remember your rule on that. If this is 3, this is 3, this side is 3 square roots of 2, and that makes D the answer to 39. We've looked at quite a few, and we're coming back one more time and looking at another one of these standard equation kind. And it asks us, what is the slope of the line with this equation? So the first thing we're going to do is start rewriting it. We'll have our 3x plus 5y equals 6. Subtract 3x from both sides. Now that leaves me with a 5y is equal to minus 3x plus 6. Divide both sides by 5. And what we're going to get is y is equal to minus 3/5 x plus 6/5. So that tells me that the minus 3/5 is my slope, and my y-intercept would have been a positive 6/5. So hopefully now, after working through several of these, you've got a little better idea how to handle the slope-intercept equations and plotting points in the XY coordinate plane. Hope this helps.